In this session, we will discuss about different aspects of security and integrity related to PMUs in smart grids. Nowadays, we are in the era of artificial intelligence, and lots of problems are being solved using AI based techniques. As far as PMUs are concerned in smart grid segment, you might have seen that there are certain instances where some particular attacks can be implemented. So as far as PMUs are concerned, these are associated with smart sensing based implementations, and on such type of deployments many times certain attacks are implemented. Man in the middle attack, denial of service attacks. However, these attacks are related to networks, classical networks, but as electricity is also associated with a huge network that is associated with smart grids. Lots of wires, lots of connections are integrated, and in that particular huge network in a smart city, whether it is a small scale implementation or large scale implementation, many times certain attacks are implemented so that voltage, current, and other parameters are overloaded. And once these parameters are overloaded, in that case that particular smart grid can be damaged. And there are so many news instances where these type of implementations occurred earlier, so we will discuss about that part also. As far as PMUs are concerned, these are linked with GPS so that real time readings can be analyzed from different locations. And if these are associated with GPS system, these are associated with satellite, with some particular base stations. In that particular scenario, obviously there are certain vulnerability points, so attackers can sniff those particular points from where specific injections can be put. So we will see in this particular session. Very soon we will start the demonstration. I will show by which way we will be able to analyze the data, how to integrate machine learning and deep learning based implementations for analysis of attacks. But before that, first of all, we are discussing about the implementation aspects. We are discussing about major loopholes in current scenarios. Okay, so as far as PMUs are concerned, these are smart sensors, very accurate for measurement of electricity waves. And if certain additional load is put in that particular implementation in that specific scenario, then that specific smart grid can be damaged. Okay, so you can see that in this particular diagram some particular smart grid and different PMUs, and in that particular scenario man in the middle attack or denial of service attack or jamming attack can be done. Jamming attack means, or denial of service attack means, some additional signals, some additional load is put on that particular device or on entire smart grid for false data. So it is also associated with theft also. Okay, for example, some particular theft of electricity is going on, or such type of implementations are deployed by attackers. In that particular scenario some false data is injected, so that the administrators or those people who are taking care of that particular smart grid, they will not come to know that certain attack is going on. Okay, by injection of some false data. So there are lots of opportunities, lots of scope of research in this particular segment, how to evaluate that particular signal, how to analyze some specific false injections in smart grid so that entire scenario can be made secure. So first of all, we will see which type of attacks can be implemented on smart grids, PMU based smart grid implementations. So data injection attacks, fake or tempered measurements. Okay, fake data is put to disguise or mislead the control center. For example, some specific signals to be captured, some specific uh, control to be taken from a particular scenario. In that case, in parallel, data injection attacks are done so that same type of signal or same frequency and uh, throughput of that specific data can be put. Okay, GPS spoofing, false GPS signals. For example, some particular electricity theft is going on at particular location, and we want to disguise, some particular attackers want to disguise the administrators about fake location. If some particular forensic implementation is going on, we administrators are analyzing uh, the location from where electricity theft is going. In that case, fake GPS signals, fake longitude, latitude can be sent. And beyond this also, lots of other attacks can be deployed on smart grids, PMU based smart grids. Denial of service attacks, overloading of PMU networks, so that real data or real signals can't reach the operators. Okay, so overloading means, for example, some specific amount of signals, some specific amount of data is required to be sent to some specific network, to some specific smart grid. In that particular case, overloading is done. If overloading of data will be there, if overloading of signals will be there, obviously that specific scenario will damage. Okay, because each and every implementation, each and every network or some particular infrastructure is having some specific capacity to handle the load. If we are injecting the data, if we are injecting the signals above that specific load, in that case it will cover under denial of service. The actual users, actual end users are not able to get that particular service, whether it is the electricity based or any other network service. Its another variant is distributed denial of service attack, in which attacks are implemented from multiple locations, from different points in parallel. Signals are sent, signals are overloaded to the PMU network so that the entire grid can be damaged. And recently, this particular implementation was done, it was deployed by attackers in Ukraine. Okay, and so many other countries, whenever there is some state of warfare, now you might have seen that there are lots of disturbances in different countries. So this is also a type of attack on other countries electricity network, to damage smart grid, to damage PMU network, so that the electricity supply, network supply can be destroyed. Okay, one network supply is related to bandwidth, is related to internet. Another network supply related to electricity coverage. Okay, so that can also be damaged. And many instances occurred earlier where that specific electricity networks are damaged by the attackers, because nowadays most of the smart grids are automated. These are controlled by automated systems. Okay, man in the middle attacks, intercepting and altering PMU data. I- Whatever network is there, whatever scenario, whatever smart grid we are having, we want to sniff a particular location. For example, there are n number of locations, n number of locations in a particular city are connected to smart grid. Okay, if attackers want to damage a particular supply, for example some strategic location that that is under target of the attackers. For example, there are some residents, there are some locations associated with some political persons, some specific high profile people. Only in that particular location where high profile people or high profile politicians they are residing, that specific network can be damaged. So that is, so by which way it is done? It is implemented by man in the middle attack. Okay, which particular power supplies, which specific grid or which particular PMU is delivering electricity supply to that particular location. Okay, so that is man in the middle attack, interception and altering PMU data, overloading of signals or underloading, damaging. Okay, in classical way we call it as um, removing that specific signal, okay, or reducing the quality of signals. If we are reducing the quality of signals, in that case definitely whatever devices are running in that particular location, those will be damaged. Okay, so you can see that this one is very uh, classical example. And Ukraine power grid cyber attack, it was implemented. And recently also same type of attack is implemented. Okay, in which for number of hours electricity network was not working. Okay, so this one is news around 10 years back, but recently also a number of attacks are implemented by different type of attacks. Iberian blackout, and lots of similar implementations, lots of similar assaults are deployed on different types of networks, high profile locations, so that complete supply can be damaged. Now the question comes, if we want to secure our smart grids or PMU based smart grids to avoid such type of instances, in that case which solutions we are having, which type of preventive measures we can take. As far as current scenario is concerned, artificial intelligence based tools are available, AI based implementations we can use with integration of data science. These two technologies, these two paradigms are interrelated, AI and data science. Because at the back end of artificial intelligence, we have to analyze the data, we have to evaluate the data. Okay, now we will start the implementation part, by which way we will be able to secure our network, we will be able to analyze what is going on in a particular electricity supply in a specific smart grid, and using code or without code, how to investigate some specific patterns. Okay, so now we will see some specific implementations related to artificial intelligence. First of all, we will discuss about the data set. Okay, I'm showing you a particular data set. For example, this particular PMU data, we are we have recorded or we have logged from a particular electricity network. Okay, so you can see that there are certain records. So time, but what about the timestamp, voltage, magnitude, voltage angle, frequency, and label. Okay, label means at final level we are taking it whether it is an attack or not. We want to identify whether there was some issue with that specific record or not, whether this particular signal is correct or not. Okay, so this particular data we will evaluate, we will try to analyze using different techniques, whether some particular records are having anomalies or not. If we are having certain test data, for example, we have this particular test data, okay, this particular test data, and with this specific test data, we want to predict whether it will be having some particular issue or not, okay, or whether it is attack prone or not, okay. So there are certain instances. One instance is that from this entire data set we want to find anomalies, we want to find out abnormal patterns, okay, which are the abnormal patterns. Another implementation, if we have some particular test record that we have logged from a smart grid, in that case, how to predict some specific value. For example, this particular value is missing, or this specific parameter, this specific value is missing, then how to predict. So to solve such type of problems, we can use machine learning implementations. In Python, we have scikit-learn, TensorFlow, PyTorch. We can work with Streamlit. In deep learning, you can work with time series based method. In time series based methods, we can predict whether this particular sequence of signals are correct or not. If these are the signals which are taken from a smart grid, from a specific sensor, whether this specific sequence is correct, it is integrity based or not, or there are some suspicious patterns. To find out suspicious data, so with merger of AI and data analytics, we will see this particular part. Okay. As far as implementation is concerned, we will use two different platforms. First of all, I will show you one some implementations on Python using Colab notebook. On Python Colab, we will see how to find out anomalies, abnormal data set, abnormal patterns in signals or in records. After that, we will see how to integrate this particular implementation with RAG, with LLM. Okay, so no need to worry about that particular part. Lots of APIs available. LLM means generative AI. How to attach this particular data with generative AI. For example, we want to create a chatbot similar to ChatGPT. We want to create a chatbot similar to Copilot or Gemini or Google AI Studio. So, for example, some specific user, some end user of electricity network is having some issue. Okay, average power supply is less or high or whatever it is. They will communicate in chat box, and with this particular data, that particular end user will be given suggestions, what will be the preventive measures or which type of solution can be there. So different implementations we will see. First of all, we will see it with classical implementations with decision tree isolation forest based implementation. After that, we will see it with LLM RAG, how to fine tune this particular data with RAG, retrieval augmented generation. In generative AI, how to create a chatbot with this particular data set. At end of this particular session, I will share all of these codes to all of you so that you will be able to work on it. So very quickly, I will show you these code snippets, these implementations, and after this code based demonstration, we will see how to work with some GUI based platforms in which there is no need to code even a single line. Without writing even a single line, we will be able to code, we will be able to predict something. For example, some particular person is not comfortable in programming platform because everybody is not comfortable, everybody is not aware with programming paradigms. So how to make use of GUI based tools. So that also we will see. So first of all, we are covering the this implementation related to anomaly detection, AI based anomaly detection in this particular data set that we have recorded from a PMU Smart Grid, PMU based Smart Grid instance. So this one is, you can see that to work with anomaly detection in Python, there is a library that is known as scikit-learn. Okay, scikit-learn or sklearn we use. In scikit-learn, each and everything is available: classification, regression, data pre-processing, data analytics. If we want to find out anomalies, if we want to find out some outliers from some particular data, if we want to plot specific data set on a particular pattern on some specific conditions, that can also be done. In this implementation, what we are doing for anomaly detection, we are using ensembled learning technique, sklearn.ensemble, and in ensemble learning we will use isolation forest algorithm, very powerful algorithm. What is isolation forest? It makes different combinations, different permutations of combinations of data, and then it will find out the anomalies. It will find out which particular data patterns are not matching with others. Okay, we will be able to see. And with this particular plotting with isolation forest, we will be able to see the abnormal patterns means it may be attack, it may be theft, or any other instance, it may be man in the middle attack. So we are directly calling this particular algorithm from sklearn.ensemble, that is isolation forest. And now you can see that these this particular data we are calling in code. So time, this one voltage, angle, frequency, label, okay, or whatever it is. It can be any data, okay, not only this particular data, any type of data you will be able to take. Okay, so this particular data we are taking, and this is PMU data, and directly we are taking it in isolation forest algorithm. So this one, you can see that this isolation forest algorithm we have called. So no need to code it separately, no need to write complete function, no need to write complete code. Code of isolation forest is already given in sklearn, scikit-learn. Okay, so for research purpose also you will be able to use it. For example, some particular data we want to analyze, and without any specific coding or without long scripts, we want to implement some approach. Okay, isolation forest we are calling contamination zero point 0.4. What is contamination zero point 0.4? It means we are assuming, this is hypothesis or this is simply assumption, we are assuming how many records. Okay, what about the percentage of records which may be having some problems? Okay, for example, we are having n number of records. Out of n number of records, we are assuming that 10% records are having some problems. Okay, we are assuming that 5% records are there in the data set in which some attacks are implemented, or in which some theft patterns are there. So that we can specify. Okay, contamination, this is out of 1. Okay, 40%, 0.4 means 40%. If we are assuming that only 10% records are contaminated, in that case we can give 0.1. Random state 42, to integrate randomization so that data can be shuffled properly. Okay, and once it is done, after that we will go for its plotting part. Okay, so we will execute it. So this one, and now we will be able to see detected attacks using isolation forest. Okay, so in very few lines of code we will be able to check our predicted attacks. So at which particular point there are some attacks using isolation forest. Okay, so this one is attack pattern, this one is another attack pattern. Okay, so if we are assuming that this one 40% records are contaminated, then which 40% out of this particular record, which 40% records are integrated with that? Okay, so if we are assuming, so on the basis of assumptions we can check those suspected records which may be having some problems or which needs detailed analytics. Okay, so you can see that this one, so predicted attacks, so out of these, this particular record is having some issue. Okay, and after forensic evaluation, after deep analytics of this particular data, this specific record from GPS, we can check whether this particular actual consumption is done or not. Okay, so if you want to see documentation of this particular algorithm, so it is available in sklearn. And not only this one, different other algorithms are also available which you will be able to work out. Okay, and estimators, how many estimators you want to attach, so you can see that, so 100 estimators. Okay, so if you want estimators means how many times we want to shuffle this data. After shuffling of this data, it will find out the possible anomalies, it will find out the possible problems, and then further investigation on that specific record can be done. Okay, if we don't want to specify contamination, in that case contamination is auto. Okay, so you can specify here contamination auto. In that case it will automatically check without any assumption. Okay, contamination is auto. Okay, or you can leave it as it is. In that case you will be able to see how many records are having certain anomalies or abnormal patterns. Okay, is this visible and clear to all participants? Kindly confirm. And I will share this particular notebook, this particular code as well as data I will share to all of you at the end of the session. Up to this point, are you getting whatever we are covering here? Kindly confirm. Okay, so this is very simple implementation, very first and very simple implementation that we have done for anomaly detection, and any number of records you will be able to process. So this one. Okay, if even you will be able to generate random records. For example, uh, you are not having some specific data set. Okay, you want to generate your own data. So within code you can call randomization functions so that that specific data can be created, and then on that specific data we will be able to work out. Okay, now one more implementation we will see related to script and classical machine learning and deep learning. After that we will come to our next part, that is very important, related to uh, nowadays AI scenario means, currently you might have seen that lots of AI based tools available, chat gpt, gemini, copilot, AI studio. So we want to create that type of scenario, we want to create that type of implementation. Okay, so by which way we can work, we can fine tune. So we will see that part also. So this one is second implementation related to defense of PMU smart grids using long short term memory, LSTM is a technique, is an algorithm in deep learning. Okay, and on CSV data, on time series based data, on temporal data, we can implement. Okay, so this is time series based data. Time series based data means that particular data which we have collected in sequence. This particular data we have collected For example, sequential data we are having, we have collected data from some smart grid, some particular PMU sensors, and on this particular data we want to see, we want to go for anomaly detection, and we want to see how many records are having some particular problems. Okay, first of all I will show you this particular data set which we are going to evaluate. 2 underscore pmu dot csv. So this is the data set, and data for, in this, out of this particular data we want to predict some particular labels. First of all, we will see whether this particular data is integrity based or not. Okay, so we can increase this specific data set. Timestamp, voltage, current level, frequency, and label. So these are the labels. For example, these are the labels, whether it is attack or not. This is not attack, this one is not attack, or not theft. You can relate it accordingly depending upon your research objectives, depending upon your work area. For example, this one is not theft. Okay, not theft. This one is theft scenario. And now we want to see whether it is this particular data is having integrity or not. This is integrity based data or not. Okay, and if we are having some particular data pattern like this one, we want to predict for this whether it will be associated with some theft instance or normal data pattern. So in that case, so we are using TensorFlow, Keras, LSTM, long short-term memory, very powerful algorithm for sequential data. For time series based data, sequential data means where we use LSTM. If we have data in sequence, whenever we collect data from network, whether it is electricity network or computer network or cloud data center or any similar instance where in sequence data is collected, network log files are also time series based data. Okay, and that particular time series data we want to evaluate whether this specific data set is correct or not, or which particular patterns are having some abnormal uh, instances, some abnormal records. Okay, so for that we use LSTM, long short term memory. Either we use LSTM or we use GRU. Okay, gated recurrent unit or long short term memory. These are under recurrent neural networks. Okay, so it's up to you whether you want to use classical scikit-learn or with TensorFlow. So you can see that which features we want to uh, attach. These are the features: voltage, current, frequency, and what is the target label. Okay, so depending upon these features, we want to analyze the integrity of data set. And min max scalar to convert these values in same range. So in machine learning or in deep learning or whatever algorithm we are using, you might have seen this algorithm, this particular function many times, min max scalar, so that all values should be in same range. Okay, all values should be between -1 to 1 or 0 to 1 or -10 to 10 or whatever it is. Okay, or we want to confine all values from -5 to 5. Here what is the problem in actual data? For example, this is the data we have captured from smart grid, from PMU smart grid. Okay, so this one is 1.02, this is 0.95, this is 50.01. So there is a huge difference. Okay, these two values are near to 1, these two values are near to 1, but it is beyond 50. This one is also 49.10. Okay, this one also 50.02. So if we will process this particular data in machine learning or deep learning or whatever algorithm is there, in that case prediction will be very very bad. So this point should be noted very carefully, that without using min-max approach, prediction on this particular data will be very very bad until and unless we confine this data in same range. So this particular data should be in same range. For example, so this is already in 0 0 1. Okay, so 1.02, so this should be in -1 to 1. This value should be converted to -1 to 1 or 0 to 1. This 50.01, this value should also be converted between same range. It means all of these values should be in same range. Otherwise, what will happen? 50.01 is the frequency. Frequency will take, or frequency will dominate the entire prediction. Maximum or high, or the prediction will be taken depending upon frequency only. I'm repeating this point. If we will not use min max scalar, if we will not convert these values in same range, in that case frequency will dominate the entire prediction. Why? Because frequency is having highest value, it is having largest number. Okay, so this is also largest number, 49.10 in other instances also. So to avoid this particular thing, that certain column or certain attribute should not dominate the prediction, it should be converted in same range. To convert in same range, we use this function. Scalar is equal to min max scalar. So what it will do, it will convert all values, voltage, current, frequency in same range, whether it is in -1 to 1 or 0 to 1. So we can specify it though. So this particular function is also given in sklearn. So because many times this question arise, that how to decide that what should be the range. So you can see that in this way, feature range 0 to 1. If I want to specify -1 to 1, so we will write here -1 to 1. If I want to confine all values in 0 to 10 or 0 to 5, in that case we will specify. So this is mandatory task. If we will not use min max scalar, in that case your predictions will be okay, predictions will be available, but will be very very bad. Okay, we will not be able to rely on those predictions. And after that we will go for this particular neural network, this specific long short term memory, sequential network. Okay, relu activation function and sigmoid activation function. Why relu activation function we have taken? So this actually activation function decides the process or computation inside a particular network. Okay, by which way computations will go on, by which way manipulations will go on in a particular neural network, whether it is recurrent neural network or it is a classical neural network. Okay, or it is some classical machine learning algorithm. So what relu will do, relu will uh, give big jump from a particular level of algorithm to next level. For example, I'm giving you one example here. So this one, so I'm opening notepad. For example, we are working on machine learning or deep learning or whatever it is. In 10,000, in 100 iterations we are having 99.2% accuracy. Okay, in 1000, in 2000 iterations we are getting 99.21% accuracy. In 50,000 iterations, we are getting 99.2 this 1% accuracy. So this is the major problem. Even in 50,000 iterations, in 2000 iterations, we are not able to achieve 99.3% accuracy. We are not able to move out. We are not able to jump from this level. If we will apply relu here, for example, I have applied relu here. In that case, what will happen? For example, relu is applied here. After that, this particular accuracy will move to this one. Okay, so what relu will give, it will give, relu provide big jump in machine learning, in artificial intelligence. This is the technique, and it avoids the gradient descent problem, big jump from particular level. Okay, so if we are stuck at a particular level, in that case we use relu. In most of the implementations of deep learning, you will see this activation function sigmoid, because we are having final label class. Okay, we want to predict a particular final value in true or false. What is true or false? So this one, 0 or 1. Final label is 0 or 1. Okay, so this one, if we have multivariate values, if we have multiple outputs or multiple values in the output, in that case we will not use sigmoid, we will use 10h, we will use sin h or other activation function. But if our final variable is 0 or 1, true or false, yes or no, in that case we use sigmoid. Okay, in how many batch size we want to predict, so that we can specify, and after that we execute it. So now we'll see. So that particular file we will upload here, that is 2.2 underscore pmu dot csv, and then to check this particular value. Okay, so this one, you can see that this one actual. So these are three predictions from test data. So whatever test data we are having, so which is the test data? So from this particular data set itself, we have taken a particular test data. So this is x underscore test. So if I want to check the test data, so we can take it. Okay, x underscore test. So if we want to check for which records it is giving the output, print x underscore test. So this one, and these values are transformed, these are under min max scaling. Okay, conversion. Okay, so these are actual values, these actual values are converted to min max, -1 to 1 or 0 to 1 or whatever it is. Okay, now this is this particular implementation, you can see that it is command based. So we are performing each and everything on command based. Now if I want to give this particular implementation a graphical user interface, some particular machine learning algorithm or deep learning algorithm, we want to give a look of GUI. In that case, we make use of Streamlit platform. It is completely free and open source to give front end to our machine learning and deep learning implementations. Generally, we use machine learning to give GUI interface using Streamlit. So I will show you by which way we can work on it. So this one, Streamlit. Okay, PMU, this one. Okay, so code will be same. So but what minor modification we have done? Okay, code will be same. We have integrated Streamlit. This one, you can see, import Streamlit as st. So first of all I will show you its output, and after that I will explain. Okay, after that I will show you by which way we will be able to work on it. For example, so on command prompt, so if we want to give some specific GUI interface to our machine learning algorithm, to our machine learning implementation. Okay, so Streamlit run, and this one. So this file we are taking, PMU Streamlit. This one. Okay, so one GUI will open. Now you can see that we are giving graphical user interface to our machine learning implementation, that on that specific data which we have taken from PMU Smart Grid. So this one. Okay, PMU based smart grid attack detection. Okay, so it's up to you. If you are comfortable in Python Colab notebook, in that case you can upload your data in this way. Okay, in this format we will be able to upload the data. But if you want to work on some GUI platform, in that case we use Streamlit. Okay, so simply we will upload data here, so it looks more professional. So this data we have uploaded, which data we have uploaded? Voltage, current, frequency, attack or not, 0 0 1, and how much accuracy is there? 100% accuracy. And what about the confusion matrix? What about the predicted results? So in actual, 0, and in prediction, 0. Okay. On some other data we want to predict, for example, on this specific data, what is the accuracy? This one. So this is streamlit code. Okay. So what we have done on same data set, simply we will use this function, this particular block, st.write. Okay, st, this one. Okay, all other things will remain same. We will integrate it with streamlit so that entire implementation will be presented in form of GUI interface. If you want to plot some graphs, if you are developing some web-based application of your machine learning approach, that you can work out. Okay. So any data you will be able to take. So this is PMU attack data. So this is 47.50. This is confusion matrix. How many uh, true values? How many false positive, false negative, true positive, true negatives? Okay. So this one. Okay. In this we have used, again we have used as an ensemble learning with the random forest classifier. Which data file we are using? Any file that you will upload. Okay, whatever file you will upload, it will classify that specific data set. Okay. So with streamlit, in this way. So simply upload your data streamlit, and it will give you very accurate and professional output. If you want to deploy it on a web-based application, on some cloud, on some live URL, that can also be done. Up to this point, is it clear to all of you by which way we will be able to work on certain scenarios which we are having related to some data set, some particular smart grid based data set? So this particular data, this one is the data. Up to this point, is it clear to all of you? Kindly confirm. Now we will see how to work with some implementations related to fine tuning of data in generative AI based platforms. Fine tuning, first of all, we will discuss what we are doing here. What is the which scenario we are discussing? Okay, so first of all, I'm closing it. Okay, now use we will make use of large language model. Okay, how to create, how to work on generative AI based platforms, generative AI based implementations, to create a custom chatbot similar to chat gpt, but it will work on PMU dataset. One way is that we will use chat gpt, we will use Gemini, Copilot, whatever it is. In that case everything is available, but I don't want to use entire chat gpt. I want to create my own chatbot in which my own data will be there. For example, this particular data, these are the data sets, these are the records we have taken from PMU Smart Grids. Okay, attack, whether there was some attack or not. So 0 means normal and 1 means 1 refers to attack. Now I want to fine tune this data. This is known as fine tuning. When we update a particular chatbot, when we update some large language model, it is associated with fine tuning. We want to embed our own data. So what is use of this particular data set? What is application of fine tuning this data? For example, this data I want to fine tune. Along with this data, I want to fine tune this particular data set. Okay, for example, this one is knowledge base. We want to create a chatbot, and in that specific chatbot, whatever problems are faced by the users, whatever problems are faced by the customers, by the clients, those each and every problem, each and every aspect, we want to save in form of a knowledge base. So this knowledge base, so it is only for demonstration, 3 to 4 lines I have written, otherwise it will take lots of time in execution. Okay, in training, fine tuning, after that prediction, it will take lots of time if I will put so many PDF file. Okay, for example, you have lots of files, lots of PDF files, lots of document files related to smart grids, related to PMU errors, related to PMU problems, okay, PMU attacks. And if some user is asking some question in chat window of electricity department or whatever platform is there, in that case it will automatically detect the problem and it will give the solution. Okay, for example, I am giving my problem as a user in a chatbot of electricity department, that I am having this much load at this particular time span. We are not having power supply, we are not having sufficient power supply, or whatever it is. I am giving my problems in layman point of view. So what it will do, what this RAG LLM will do, what is RAG? Retrieval augmented generation, large language model of AI. It will analyze my sentences, it will analyze my patterns, and it will check from backend database. And after analyzing those problems, it will give the solution. So no need of any human operator, no need of any human forensic analysis. So such type of implementations are very useful for research based applications. Okay, if you are doing research in this particular domain, then you will be able to propose some research projects, will be able to propose some research tasks to specific department, that these type of chatbots can be created by fine tuning of user problems, by fine tuning of user problems and documents from the department. So for example, these are 4 sentences I want to train, and along with that, we have some particular data related to voltage, current, frequency, and attack. Okay, this is sample data we have taken. Now, depending upon this particular data and this knowledge base of attacks, knowledge base of different problems, which question I am asking. Okay, for example, I want to ask this question. Okay, how AI can detect PMU attacks? So you can see that this question. So this is the question that is integrated within this code. We can give look of this code in form of a GUI, as we have seen in Streamlit. Okay, first of all I will show you in Google Colab. Okay, so if some particular user, if some particular client is asking that this particular question, by which way AI can detect PMU attacks, so it will check out of these 4 sentences, by by which way this solution can be given, by which way this question can be answered. For that we are using this model, distill burt base uncased, distilled squad. Okay, this is known as fine tuning model we are taking, and we will use a particular pipeline question answering, and in that question answering we will put our document. So these are only 4 sentences. If I want to give n number of PDF files, n number of document files, that can also be done. Okay, so it will check by which way this solution can be given, what will be the solution, what will be answer of this particular question. Okay, so we will see this one, this particular part. Okay, predict on this particular data, and you can see that this is my training data. voltage, current, frequency, and these are attacks. These we are training. This is supervised learning. Along with supervised learning, we are integrating a chatbot so that some solution can be given to the customer or to the end user. Okay, so one question is this one, and second concern that is asked, we want to predict whether it is an attack or not. 238 7 48.7. Okay, by reading PMU data, where is my PMU data? This is my PMU data. Okay, by analyzing this entire data, we want to predict whether this particular pattern is an attack or not. For that, we will use this one. You can see this particular pattern, and for question answering, for knowledge base, to get responses from a specific question, we will use this distill bird. So now we will execute it. So two implementations, two segments we are performing here in parallel. One is knowledge base integrated response fetching, and after that we will see whether a specific pattern is under attack or not. Okay, so model accuracy is 100%. It means this data is fine, and now it is running, and very soon we will see its output also. Now you can see that this one. Okay, so it is running now. It is downloading that complete model, and you can see that this one. So whatever data we have put, so new data prediction is attack. Which data is having this pattern attack? This one data. So okay, which data we want to analyze? This particular data we want to analyze, and it is identified under attack. This is attack, and along with that we want to see answer of this question, by which way AI can detect PMU attacks by training models such as random forest. So from where this answer is fetched? From the documents, from sentences we have trained. So you can see that if I want to match whether it is available or not. So you can see this one. So this line is fetched. So if I will ask, okay, what is phasor measurement unit? In that case, first line will be fetched automatically. So what we can do, we can create a knowledge base. So this is knowledge base. If I want to identify relationship of volt, voltage overflow or current overflow or overloading of some particular voltage, association of overloading of voltage with PMU. Okay, if some particular administrator, if some specific user want to ask, so that question we will be able to put here. Okay, for example, we want to put here, okay, as a user, as an end user, okay, can we control the overloading of voltage? Okay, as a user I am asking. So if there is no answer related to this question in my knowledge base, that is uploaded by electricity department or administrators, in that case, uh, obviously it will take that particular data. Okay, if its answer is available, in that case it will be done. Okay, so for example, this one, overloading, okay, and can be controlled. Now, for example, this database, this knowledge base we have updated as an administrator. We have updated this knowledge base. So these are sentences. If we want to upload some PDF files from some particular doc files, so that can also be done. Once this entire data is trained, then end users will get suggestions what they should do in a specific scenario. Okay. Now you can see that this one. This one is the output. This one. Okay, so you can see that. So I have written, can we control the overloading of voltage? So can be controlled. So from where it has taken? So this is the question that is put by the user. So where we have written? So this is written here. So I have trained my own data. So if I want to train in this way and can be controlled by data analysis. Okay, so as an administrator, I am writing this one, that okay, it can be done by data analysis, and please, and we will analyze your data records. Okay, for example, as an administrator or as ML analyst, we are giving this all of these values, all of these parameters. Okay, so rather than these sentences, what we can do, we can upload PDF documents, we can upload complete data set, historical data, okay, from last 20, 30 years data, 50 years data we can put. And as soon as some user, some end user, some client will ask some question, it will access the complete data set, and it will give the solution. So you can see that, yes. So what I have written in the question, can we control the overloading of voltage? Can be controlled with data analysis. Okay, this one. And these are attacks, and this one. So this is known as fine tuning. What we are doing, fine tuning, hyper tuning, hyper parameter tuning, by which, so if I am giving some other question, for example, as a user I am giving a specific question. Okay, detection of, okay, how to detect anomalies. Okay, for example, as a user I am asking, as an end user, some client is asking by which way we will be able to work on some specific instance, or not as a user, as an administrator also, as a particular expert also we want to analyze, as an engineer also we want to analyze. So we will see what is the output. So you can see that how to detect anomalies. So its answer is by training models such as this one. So to administrator, to strategic managers, to engineers, it is giving that particular result. Now one more similar type of implementation we will see. Okay, so you can see that this one. So AI, for example, as a user, I am asking what is AI PMU attacks. Okay, from whatever data we have trained, it will fetch the answers. Okay, so this one, false data injection. So along with prediction of data, what we can do, we can integrate a complete knowledge base, and that particular knowledge base will be used to integrate a particular AI chatbot with our own records. Okay, for example, specific to electricity department, specific to smart grids, specific to PMU instances, we want to create a custom chatbot. So this is the instance. Another example we will see in similar way. So for example, this one, okay, in natural language processing, for example, same type of scenario we want to train with natural language processing. Okay, if some particular user is sending some particular message, or there are certain log files. Okay, these are the messages. For example, voltage and frequency stable, this one normal power. So whether these are attacks or not, so these are already recorded in electricity department, in that particular smart grid department, that specific managerial level, these things are already recorded, that if these instances are there, then it is attack or not. So if sudden fake voltage, then it is attack. If normal power, it is not attack. Okay, so in third, injected false data, it is attack. So this particular data set, this particular these knowledge base, these are already with a particular department, with a specific scenario. Now whatever new data is coming, we want to predict, okay, whether that new pattern is matching with these patterns or not. For example, as a user or as an administrator or as an engineer, I am asking that I am having fake PMU readings, or I am having overloading of signals, overloading of data. Is it certain instance of cyber attack or not? So it will analyze the entire data set, it will investigate the entire knowledge base, and then it will predict whether my message or whether my concern is associated with some attack or not. Okay, so in this case also we can train our data. Okay, so this one, any number of records. So just for demonstration, I have put 7 to 8 records here, 7 to 8 sentences. So you might have seen in every department, in every instance, whenever some log files are created, some comments are done. For example, some problem is there, some issue is there. Okay, that issue is resolved. Along with that particular resolution of issue, some messages are put. So, for example, this is first message. Okay, that certain complaint was there, and in that particular complaint, no attack. Okay, certain complaint was there, it was an attack. So these are already recorded. Are you getting what I am covering here? Kindly write in chat window. Kindly confirm. First of all, kindly confirm. Are you getting what we are covering here, and what is use case? In chat, kindly confirm. Okay, so whatever log files are available, whatever messages, for example, some issue. Okay, so these are 7 to 8 messages. So this is issue one or complaint one. Okay, complaint one. This is complaint 2, this is complaint 3. Okay, so it is only for example I have written here. These are n number of complaints. So first complaint was not attack, second complaint was not attack, third complaint was attack. So these, all of these data sets are already available with the department. Everybody knows that whenever certain complaint is there, whether whenever certain issue is there, after resolving that issue, it's some comments are given that it is resolved, and this was the problem. These are, all of these things are already recorded in the database. Okay, this is the knowledge base or database, whatever you can say. Now I want to train these records, I want to train this entire data set, and I want to make a chatbot. We want to create a chatbot, okay, similar to chat gpt, so that as soon as administrator or engineer will put some particular comments or will try to analyze some particular keywords, that engineer will come to know how much probability is there that it is an attack, how much probability is there that it is a normal traffic. Okay, so this particular data we will train, and using hugging face. Okay, so in same way we will use this particular distill BERT base uncased. So you can explore these models. All of these models are available on Hugging Face, on Olama, on Gen AI, on different platforms. These are available. These are AI based platforms to create your own chatbot. If I want to create my own chatbot related to the problems, I want to train my own model. Okay, so this particular I want to train, and now what is my question? For example, this is my question, that my PMU shows a fake data injection, whether it is an attack or not. Okay, or I am getting, for example, uh, as an engineer, I'm sending this message, or I'm trying to check this message that PMU showing fake data or overloading of data. Okay, now I want to predict whether it is an attack or not. Okay, how much probability is there that it is an attack? This particular issue is related to some cyber attack. Okay, or this one, any Any question you can put, whether as an administrator or as an end user. Okay, so that particular chatbot can be made available for engineers as well as end users. Okay. So for example, this one, and we are training it, and we will predict whether this particular sentence is matching with these sentences or not. So it is under natural language processing, but that particular natural language processing, we are linking it with different issues and their labels. So these are issues. So these are issues, and these are different issues, and these are labels, and we want to predict a new issue or new complaint, whether that particular new complaint is associated with some attack or not, or that particular complaint should be treated with remedial measures towards cyber attacks. Okay, so it is running. So how many epochs? So we can see these iterations are running 7 by 9, and very soon we will see its output, that this particular sentence which we want to predict whether it is associated with some attack or not. So it's up to you. If you have numerical data, you can use regression, you can use a decision tree, isolation forest. If you have uh, some particular data, linguistic format based data, that can also be linked. So now you can see this one is input given in chatbot, and its prediction is attack. PMU shows fake data injection is in voltage. I want to check whether this sentence is exactly available or not. Okay, this, so PMU data fake injection, so you can see that that sentence is not available exactly. That particular sentence, PMU data is having fake injection. So that sentence is not exactly available in these lines. Okay, so PMU is available. So it means it is not checking, it is not matching that particular sentence exactly. It is matching the patterns. Okay, by which way PMU with combination of fake with combination of data is matching with these patterns. Okay, in same way, for example, some other custom output we want to predict, this one. Okay, PMU, for example, some complaint is there, PMU with overloading of voltage. Okay, so we want to see under which category it will come, attack. Okay, if we want to plot it, then we can use tensor board. Okay, so for research point of view, so what we can do, we can put this one, tensor board. So what is tensor board? If we want to analyze complete data set in form of graph, so this is also free and open source available. Tensor board, TensorFlow's visualization toolkit. So whatever operation you are performing, whatever implementation uh, im- you are deploying, so you want to generate graph of accuracy matrix, accuracy, the graph of confusion matrix, graph of error. Each and everything can be done. So with the tensor board or WAND B, WA and B, either you can use WAND B or you will be able to use tensor board. So WAND, this is WAND B. Okay, WANDB.ai for evaluation and plotting of results. In 2 to 3 lines of code, we will be able to work on it. WAND-B or tensor board. So you can see that in only 2 lines, this graph is generated. So what we have written, load extension, tensor board, and tensor board. Automatically, whatever previous implementation is available, okay, whatever implementation we have done previously, automatically its graph will be generated. Okay, so you can see that. histograms, and different other parameters, scalar values, time series analysis. Okay, these values. So for research purpose, these are used. Okay, so along with numerical data, you will be able to work with some particular text data to train a particular uh, machine learning deep learning model. Okay, when we work with large language models, then generally it is associated with deep learning. So this one is numerical data. Along with this particular numerical data, we have integrated our knowledge base, and with this particular knowledge base, we want to give suggestions to the end users, customers, clients, or whatever you want to say, or to the strategic managers, to engineers. We will be able to give it. Okay, so this code also I will give, all of these scripts I will share to all of you, so that you will be able to work on it. Is this clear to all participants? Kindly confirm whatever we are discussing. Is this clear to all of you? In chat window, kindly confirm.
Yes, sir.
Okay. Now, dear participants, very quickly we will discuss about one platform, one tool, GUI based tool for AI based implementations. However, it is used for data science and analytics, but it can be used for data science also, for artificial intelligence also. That is data analytics, AI based predictions with Orange tool. Okay, so very quickly I will show you. It is free and open source available. So if you are not comfortable in Python programming, if you want to work with GUI based tool, then Orange tool, completely free and open source available. You will be able to work on it. So I will show you one implementation very quickly in Orange tool. Classically, it is for data mining and data analytics, but it is having lots of algorithms associated with artificial intelligence. Okay, if you want to work with machine learning, if you want to work with supervised learning, unsupervised learning, data visualization, each and everything is available in Orange tool. Okay, so you can download this tool. It is completely free and open source, and there is no need to write even a single line of code. You will be able to import artificial neural network, random forest approach. You will be able to import different blocks related to data pre-processing. Everything is available. Okay, so I will show you its implementation, by which way you will be able to work on it. Okay, so if you want to download this tool, you can work on it, and it's a screenshot. So meanwhile it is loading, I'm showing you its screenshots. So if you want to work on, for example, some specific data sets, you can use it. Okay, because nowadays lots of GUI based platforms available. So you can see model based feature scoring, classification of data, data pre-processing. If you want to plot some particular graphs, these are available. Okay, so most of the algorithms related to machine learning are already available, already integrated in Orange platform. So this is the tool. It is loaded now. Now this is Orange. Very quickly I will show you one demonstration. For example, I want to import some file. So you can see that this one is file. Which file I want to use? Okay, data file. if I which algorithm I want to use. Okay, if I want to import data from SQL table, that can also be done. So visualize, evaluate, machine learning, deep learning. Okay, for example, I want to use this one, neural network. So you can see that this one, neural network. Any algorithm you will be able to import, and we can go for its prediction. So it is loading now. Okay, it is taking some time in loading. So once it is loaded, then I will show. So you can see that neural network. So multiple neural networks, random forest approach. So for example, the one particular file I want to read. Okay, so that we can take. So which algorithm we want to take? For example, this ROC analysis. Okay, in model I want to take, for example, gradient boosting, naive bayes classifier, logistic regression, or tree, or support vector machine. So you can see that this one, support vector machine, any algorithm we will be able to take. Now what we will do, we will simply link it. In this way we will link. Okay, so which file we want to read? So one scenario I have already created, I will show you. So this one, after importing blocks, simply drag and drop, as simple as MS Word, as simple as paintbrush. Okay, no need to work on coding part. Okay, simply file, data sampler, random forest, logistic regression. So you can see that drag and drop, simply from left hand side panel we have dragged. So which file I want to read, double click. Okay, so I want to take this particular train.ts.csv file. This is my target, and this one. Okay, data sampler, double click. So where is data sampler? From left hand side you can see this is data sampler, simply drag and drop. Logistic regression, drag and drop. Random forest approach, predictions. So no need to write even a single line of code. Okay, without coding, without programming, without scripting, simply by selecting a particular file you will be able to work. Now I want to see output from logistic regression, and we want to see predictions. So on double click of predictions we can see these are the predictions. Okay, so in logistic regression it is giving this zero prediction, and in random forest approach this one. Okay, I want to see some specific prediction. Show classification errors, so some errors we want to predict. If I want to see confusion matrix, simply double click, and you will get that confusion matrix. So you can see this is confusion matrix. So no need to write any script, no need to code anything. If I want to plot something, for example you want to visualize anything, so simply drag that particular block. Okay, visualization, tree, box, violin plot, or scatter plot. Okay, what we want to visualize. So whatever data we are taking, we want to visualize. So you can see that this one. Okay, so scatter plot, I want to go for bar plot. So this is bar plot, drag here. Okay, so what is, wherever our data sampler is available, so data sampler will be linked to bar plot. Double click. Now this is bar plot. Bar plot of which parameter? P1, P2, P3, whatever it is. So it's up to you. If you are comfortable in programming part, you can go for Python, you can go for TensorFlow, scikit-learn. If you want to work on GUI part, graphical user interface, without coding, drag and drop. So in that case, you can use Orange tool. So this, you can see that all of these algorithms available for visualization, evaluation, test and score, prediction, confusion matrix. In case of Python, we have to write everything. We have to specify the syntax of confusion matrix. We have to write syntax of that particular prediction model training. But here, no need of that particular thing. Simply double click and specify the parameter. Okay, which I want, which regularization technique I want to apply, lasso, ridge. In case of Python, we have to write it in script. But in this particular platform, Orange, no need to write anything. Okay, simply double click, get the output. Okay, double click on predictions, get the predictions. Double click on confusion matrix, get the predictions, get the output of confusion matrix. So each and everything is available in GUI mode. If you want to integrate Python code, so Python script is also available. So you can use this tool Orange for GUI based programming, visual programming. No need to write anything. All machine learning algorithms available. Okay, so you can explore it. Now, dear participants, I am sharing this presentation to all of you. Whatever I have covered in this session, I am sharing this presentation as well as the codes. And just a minute, I'm uploading this, all of these files. PMU, these data sets also I'm sharing. This RF file also I'm sharing. PMU Streamlit also I'm sharing. Okay, upload more files. Okay, so now, dear participants, link of the presentation and source code I have shared in chat window. Kindly confirm is it downloadable or not. And now session is open for your queries. Dear participants, I have shared link to download the presentation.